Okay, so we're going to graph functions today, all right? So this is the exact thing we were exact same thing we were doing in chapter 2, except now we're just calling them functions. Now, the only difference is, I would say, on these directions at the top right here, is the first thing you have to do is you have to solve for y. So some of these do not have y all by itself. So I want you guys to note that first, all right? So this thing right here. So you may have to solve for y. Then you're going to plug in the x values. Those are going to be your inputs. Then you're going to get your output or your y values, and you're going to graph those as ordered pairs. And then you're going to, well, in some cases we're going to connect the dots, and others we're not. All right? And then we also want to know from chapter 2 whether the graph should be a U shape, a V shape, or a line. So the first problem. You guys see right here, this is not solved for y. So let me zoom in on that. So this one right here is not solved for y, so we need to do that first, okay? So we're going to write solve for y. So solve for y, we got x minus 3y equals negative 6. Now I want to get that y all by itself, this y right here. So how am I going to get rid of this negative 3 here and this x? What would you guys do first? How do we get rid of this? How do we get rid of this x here?
Subtract x.
Yeah, subtract x on both sides. So we want to subtract x on the left side. We're going to subtract x on the right side. These are going to cancel out and make 0. So now we have negative 3y equals, and on the right-hand side, those do not combine. You have to leave that as negative 6, take away x. And then how do we get rid of that negative 3 right here? Good. Yeah, you're going to divide both sides by negative 3. Now notice I divide that entire right-hand side by negative 3. These will cancel out and make a 1. So I end up with y equals negative 6 minus x all over negative 3. All right, and then they give us our domain values. Do you see that? So they're giving us our inputs or our x's right here. That's all we have is those 4. So when we set this up now, we're just going to graph 4 points. We're not going to connect them. All right, just 4 discrete points. So let's see, let's move over here a little bit. So to get the first one, well, let's make a little table for this thing then. Or maybe I should do it to the left over here. Do I got more room? Yeah, I could probably do that. So over here on the left-hand side, I'm going to make a little table. So I'm just going to write down, make this table, make x and y. And I'm going to plug in negative 3. So negative 3, 0, 3, and 6. And I have to plug those into my function. So my function is right here. I'm going to replace this x right here with those 4 different input values. Now, if you want to, a lot of you guys, that's a lot of negatives for you guys. If you struggle with that, I would use the calculator, okay? But if you're going to put this in the calculator, you're going to need to put this numerator in parentheses like that. So for the first one, I'll set it up for negative 3. It would look like this. You'd have y equals a parenthesis, then negative 6 minus negative 3 all over negative 3. Now, do you guys see that I put the negative 3 in for x right here, right? So I put it in parentheses. Okay, the thing that I'm substituting in or that I'm plugging in, I put it in parentheses right here. So then again, if you guys struggle with the positives and negatives still, I would just type this thing in my calculator just exactly like I wrote it right here with the parentheses and everything. But let's try to do this. What do you got to do when you subtract a negative right here? When you subtract a negative, you do what? Come on, guys. When you see minus a negative, what do? You add. You add. So this numerator is just going to be negative 6 plus 3. What's that? Negative 3 divided by negative 3. 1. So this should be a 1. All right, then I'm going to plug in 0. So let me do that. So right in here, we're going to put 0 instead. So put 0 in for the x. What's negative 6 minus 0?
Negative 6.
Divided by negative 3?
2.
Yeah, that one's 2. Then we're going to put a 3 in for the x. So right in that spot right there, we're going to put the 3 in. So what's negative 6 take away 3 more?
Minus 9.
Negative 9 divided by negative 3.
3.
That's 3. And then the last one we got to put in is 6. So again, it's going in this spot right there. So I'm putting 6 in. So what's negative 6 take away 6 more?
0. Or no, sorry, negative 12.
Yeah, negative 12 divided by negative 3. That's a positive 4. All right, now, back from chapter 2. If this equation has a x to the first power in it, do you remember what the graph was? So I'm looking up here, right there. That's an x to the first power. Was that a V shape, a U shape, or a line? When it's x to the first power. Anybody remember? That's if you have x to the second power. This one, yeah, you're looking at this up here, Rachel, this thing. So that thing right there, that has x to the first, yeah, it's a line. That has x to the first power. When it's an x to the first power, that tells you that this should be shaped like a line. So it should be a line. Now, if we don't get a line, then we messed it up. Okay? And then we're just going to plot these points right here. So it's just like that homework problem that I showed you from Friday. You just fill in the table, but now we have to graph the points. Okay? We're going to graph the ordered pairs. So let's see if we get a line. So let's go. The first one is negative 3, 1. That's 3 to the left, 1 up. So that'd be like right here. The second one is 0, comma 2. So I don't go left or right at all. I go 2 up. The next one is 3, 3. That's 3 to the right, 3 up. And the last one is 6 to the right, 4 up. It doesn't quite fit on the grid. So we'd have 6 to the right and 4 up, which would be like up here. So that would actually be the point, that one right there. That's actually 6, comma 4. Now, do you guys see that they lie in a straight line? You got a straight line right here, right? But you don't connect them on this one. Hold on. Don't connect them. All you have is these 4 domain values right here. So that means you plot 4 discrete points. That's it. Let's go to the next one. So number 2. Is this one solved for y already? What's f of x the same as?
Y.
Yeah, that's the same as y. So this thing right here, this is the same as y. So that's already solved for y, so we can go ahead and make the table right away. So for this one, again, they give us these 5 domain values right here. So we're going to make a little table again. And we got -2, -1, 0, 1, and 2. Then I just got to plug them in, right? So we're just going to take these, like for example, we're going to take -2 right here. We're just going to plug that in for the x. So that's going to look like y equals -2 squared minus 3. Again, on those TI calculators that you guys are using, make sure you put that, if you want to type that in the calculator, make sure you put the negative numbers in parentheses or it'll mess it up. Okay? So we put -2 in there, -2 squared. What's that? -2 times itself. That's 4. 4 minus 3. That's 1. Then we're going to plug the -1 in. So we'll put -1 in right there. So -1 squared. That's 1. 1 minus 3. -2. Then we're going to put 0 in. Now you guys should probably write all these down, but I mean it's easier for me to I can just erase them on the whiteboard. So we're going to put in 0. 0 squared minus 3.
-3.
Yeah, 0. It's going to be 0 minus 3, so it's -3. Then we're going to put 1 in. So we put 1 right there. 1 squared minus 3. That's 1 minus 3. -2. And then for the last one, we got to put in 2. So we put 2 in. 2 squared minus 3. 2 squared is 4. 4 minus 3 is 1. All right, now this one. This problem, you've got y equals this function. I guess I'll write it as a function. So this function was f of x equals x squared minus 3. This one right here, this has a squared in it, right? So when you look at that and you see that x squared, is that going to be the line, the V shape, or the U shape? Anybody remember from chapter 2? Yeah. Which one?
U-shape.
Yeah, it's the U shape. Good. So this should be a U-shaped graph. Now the reason I keep reminding you of that is because if you don't get a U-shaped graph, then you know you messed it up, right? It's kind of self-checking here. If we get a U-shaped graph, we know we did it right. So let's plot the points. So the first point is -2 comma 1, so that's 2 left, 1 up. The next one is -1 comma -2, that is 1 left, 2 down. The third point is 0 comma -3, that's just 0 left or right, so it's just 3 down. The next point is 1 comma -2, that's 1 right, 2 down. And then the last one is 2 comma 1, that's 2 to the right, 1 up. So here, I'll label that one. So that one right there, that's 2 to the right, 1 up. Is it U-shaped?
Yes.
Yes, and you know you did it right. Do we connect the dots on this one? No. No, we've got 5 domain values, that's all. So we just plot those 5 points, we're done. All right, ready? Let's do another one. This one again, first thing I'll note on here says choose your domain. That means your domain is actually, it's all real numbers. Well, if it's all real numbers, you can choose whatever you want for your domain. You could choose any real number to plug in for x as your input. You could do negative numbers, you could do positive numbers, you could do fractions, decimals, whatever you want. For this one, I think I'm going to go, well, first of all, we got to solve it for y, right? So we got to have that note again. Let me write that. You need to solve for y. So right now we've got 2 equals y plus 3x. So we're trying to get this y all by itself right here. So how do we get rid of that plus 3x? Good. So we want to subtract 3x on both sides. Then these will cancel out on the right-hand side and make 0. So we get y equals 2 minus 3x. All right, now we need to make a table. I think this one I can probably fit it over here. So I'm going to pick -2, -1, 0, 1, and 2. Those are going to be my x's or my inputs. All right, so the first one I got to plug in is -2. So I'm going to take -2. I'm going to put it right in there for x. So that's going to look like y equals 2 minus 3 times -2. So on this one, what's -3 times -2? -3 times -2. Yeah, right here, I'm doing -3 times -2. I'm doing order operations, right? I have to do this multiplication right here first. So I'm doing -3 times -2. That's a positive 6. So that's going to give me 2 plus 6. What's 2 plus 6? It's 8. That one's 8. Then I'm going to plug in -1. So I'm putting -1 in those parentheses. What is -3 times -1 right here? That's a positive 3. So since it's a positive 3, I'm going to write 2 plus 3, which is what?
5.
That's 5. Then I'm going to put 0 in. So put 0 in for the x. So that's going to be a 0. What's -3 times 0?
0.
That is 0. So this is going to be 2 minus 0, right? What's 2 minus 0?
2.
That's 2. Then I'm going to put 1 in. So I put 1 in as my input. What is -3 times 1? So I get 2 minus 3. 2 minus 3 is? Good, -1. Then I'm going to put 2 in and I'm done. So I put 2 in right here. What is -3 times 2? Right here. That's a -6. So I'm going to write 2 minus 6. Because that 6 is negative. What's 2 take away 6? Good. All right, now this one. This one has if you look back, this has a x to the first power right here. So what kind of graph am I going to get? Again, I'm looking right here. If it's x to the first power, Neve, what was it? That's a line. So since that's a first power right there, I know that this thing is going to be a line. So when I graph it, I better get a straight line. If I don't, then I know I messed it up. So let's plot the points. First point is -2, 8. Is that going to fit on my grid? You guys right there? I've got a y value on this point of 8. It's not going to fit on my grid, is it? I'm going to skip that one then. The next one's -1, 5, so I go 1 left, 5 up. That's going to put me like up here. Then I'm going to do 0, 2. 0, 2 puts me right here. Then I've got 1 comma -1. That's 1 to the right, 1 down. That's right there. Last point is 2 comma -4. That's 2 to the right, 4 down. That's right there. Do I got a straight line? Yes. Do I connect them?
No.
Well, my domain is all real numbers. That means this chart that I made right here, I can make that as long as I want. I can put fractions in there. I can put decimals. So that's going to fill in all the points in between those 4 points that I plotted then, right? Exactly. Yep, so you got to connect the dots on this one. So let me do that. That would look something like that. If you miss, you just make the point a little bit larger there. And I could put really big numbers in for x, right? Like I could put 100 in there for x. I could put negative 50 in there for y. So you put arrows on the end of this too. Okay? Because you can pick really big x values and very negative x values. All right, let's keep going. What do we got, like 2 or 3 to go? All right, this one. This one has absolute value in it. So what's the shape of the graph? What's that?
Is it like a V?
It's a V. Yeah, this one, you see the absolute value symbols here? Then you know this should be a V-shaped graph. It's supposed to be a V. So V-shaped. And then if we don't get a V-shaped graph, then we know we messed it up. This one is already solved for Y. All right, G of X right here, that is the same thing as Y. So this one is just Y equals absolute value of X plus 2. So for this one, I'm just going to pick, I don't know, I think I'm going to pick the same values I used before. Again, it says choose your domain, right? So when you see choose your domain, when you see this thing, hold on. When you see that, that means your domain is all real numbers. So all reals. All right, so I'm just going to pick the same ones I did before. I'm going to do -2, -1, 0, 1, 2. Now, hopefully that'll be enough to show me the V. Okay, it's supposed to be V-shaped. So if you start plotting these points and you only get something like this, that means you need to pick more X values because it's supposed to be V-shaped. So if you do that, if you pick more X values, then eventually you should see it turn around and start going back up the other way, okay, like that. You're supposed to get a V-shaped graph. All right, let's see what you can do here. So we're going to take -2, and we are going to put it into the absolute value right there for X, right there. So that's going to look like Y equals the absolute value of -2 plus 2. What's the absolute value of -2? 2. 2 plus 2 is? This one's 4. Then we put -1 in. So if we put -1 in, that's our input for X. Absolute value of -1? 1 plus 2? That's 3. Then we're going to put in 0. Absolute value of 0? 0 plus 2? That's 2. Then we're going to put in 1. Absolute value of 1? That's 1. 1 plus 2? All right, can you see we got the same thing as we got up there at -1? You guys see that? We got the same Y value at X equals -1 as we did when X was +1. We got the same thing. We got 3. That's what's going to make the V for us. And then the last one, we got to plug in 2. Absolute value of 2? 2 plus 2? There we go. So we just got to plot these points. Hopefully we'll get a V shape. All right, so the first one is -2. Now you guys see what I'm doing, right? My first point's right here, right? That's my first ordered pair. So I'm going to plug in, or I'm going to graph this. So I got -2, 4. So I'm going to go 2 to the left, 4 up. Then my next point is negative 1 comma 3. That's 1 left, 3 up. Then my next one is 0 left or right and 2 up. And my next point is 1 comma 3. That's 1 right, 3 up. My last point is 2 comma 4. That's 2 to the right, 4 up. Is it V-shaped?
Yes.
Yes. And then do we connect it? Yes. The domain is all real numbers, so we're going to connect the dots here and put arrows on it. So our final graph should look like this. You guys good with that one? All right, the next one will be real quick, okay? So I think we got to flip the page. So the next one, all right, so first of all, I don't like the x value they chose on this, so everybody change this right now. They want to know what is f of x if x, right here. The question is, what is f of x if x equals negative 4? Let's change that to a negative 3. I don't want to do this with a bunch of fractions in it, so change that value right there to negative 3. And then what is f of x the same as?
Y.
That's the same as y. So really all they're asking you is what is y if x is negative 3? Well, that's the same thing we've been doing, right? All you're doing here is they're just saying, okay, I'll make a little chart here for you guys. There's x and y. They're saying x is negative 3, find the y value, that's all. But the difference on this one is you have the graph. When you have the graph, you can go read that right off of the graph. I mean, yes, you could take negative 3, and you could take that negative 3, and you could plug it in right here for x, right? And you could find the y, if you want to go that way. That's how you do it algebraically. But if you have the graph, you can just read it off the graph. So just go to negative 3 on the x-axis, which is right here, and then just read up here till you hit the graph. What's the y value right there? Yeah, it's 6. You can't see it very well, but this is negative 3 right here. That's 6 up there. Yeah, so you're just trying to get the y coordinate of that point right there. So then the answer to this question is, well, it's 6, right? So it's negative 3 comma 6. Now, if you want to be fancy, you could write f of negative 3 equals 6. But I told you guys I think that was on Friday, I told you guys that that's just a fancy way of saying the point negative 3 comma 6 is on your graph. And you can see that up here. That's the point negative 3 comma 6 right there. All right, so if they give you the graph, use the graph. Just read the point right off the graph. And then the last one. This one says a mouse can run 3.5 meters every second. They already give you the function, so they give you that right here. And it says graph the function and then estimate how many meters the mouse can run in 2.5 seconds. So your equation here is y equals 3.5x, where x represents the number of seconds. All right, we probably want to zoom in on this graph and actually label what this stuff is. So on the x-axis here, this is the time, and that is in seconds. And then on the y-axis there, you have the distance. So this is the distance. And that is in meters. And then we got to make a graph. Well, we already have the equation right there, so all we got to do is plug in some x values. Now we're doing 3.5 times x. You got to pick some x values where it's going to fit on the grid, you know what I mean? Like, do you want to put 6, well, Let's do something easy. Do you want to put 4 in there for x? If you take 4 and put it in right there, what's 3.5 times 4? Here's what I'm doing. I'll erase it in a second. So I'm saying, so if I want to take 4 and put it in there for x right there, that's not going to work real well because 3.5 times 4, that's 14, right? Does that fit on the grid? What's my highest y value on my grid? What? Sid, what was that?
6.
Yeah, our grid only goes up to 6, so we don't want to include an x value of 4 because our grid only goes up to 6. All right. So 3 times 3.5. If I do 3, I don't think that's going to fit on there either, is it? 3.5 times 3. That's what, 10.5? Does our y values go up to 10.5? No. So I'm thinking we're going to have to just pick like 0, 1, and 2. And that's part of your homework, okay? Your homework today is on a worksheet. And the reason I did that is because then all the graphing grids are already on there for you guys, okay? So you don't have to use graph paper or anything. But when you get to a problem like this, you got to think about it a little bit. Like I said, you don't want to use 3 for x here because it won't fit on your grid. Your y values don't go up to 10.5. So let's just do 0, 1, and 2. So we're going to do 0, 1, and 2. So we plug in 0. Plug in 0 for x right there. What's 3.5 times 0? 0. Good. Thank you, Cameron. What's the next one? What's 3.5 times 1?
3.5.
3.5. Thank you, Cameron. What is 3.5 times 2?
7.
7. So those are the only points we're going to try to plot then. So 0, 0 is going to be right here. 1, 3.5. We're at x equals 1. We got to go up 3.5 squares. That puts us right in the middle right here. And then at 2, we got to go all the way up to 7, which is going to put us x equals 2, y equals 7 is going to be up here, right? Do we connect them?
No.
Can we have a half a second?
Yeah.
Yeah, or a quarter second or whatever. Yeah, so we're going to connect them. I am going to put an arrow on there, but you don't really want to put an arrow going the other way because you can't have a negative number of seconds. So I'm going to let the graph stop down here, right here. All right, now we got to use the graph to predict the distance at 2.5 seconds, right? I think that's what the question was, right? Yeah, how far can the mouse run in 2.5 seconds? That is right here. So we gotta go up and hit, well, that's gonna be kind of tough to do, isn't it? It's kind of this, I don't know, they didn't put a very nice grid on here. I think they kind of messed this up. Because we gotta hit this graph at 2.5 seconds. Let's try. So at 2.5, I gotta go up here and hit the graph. So go to 2.5 and then come up here. So let's see if we number this a little better here. This would be like 7 right here. That would be like 8. And then you'd have 9 up here. You guys kind of see that? So the grid didn't fit very well here. So we are somewhere up here, right? Kind of hard for me to draw it on here, but it's up here. And let me make this a little, I'll try this, hold on. Let me undo that and make this thicker. So we're up here somewhere.
So like almost 9 seconds.
Yeah, we're up there somewhere. Can you guys see that? That's really hard for me to get that to show. Let me try a different color. We're up here somewhere. We're at this point right there. And that's at 2.5. So it didn't fit very well, but hopefully you can see it's somewhere up there between 8 and 9. You got it? 9 is right here. So I don't know, 8.5, something like that. That's about the best you're gonna do probably. So we're gonna estimate that when X is 2.5 seconds, the mouse can run somewhere between 8 and 9 meters. So we're gonna do, I guess I'll just write it down. So somewhere between 8 and 9, I guess about the best I'm gonna do is say 8.5 meters. And again, that's approximate. Yeah, in 2.5 seconds, the mouse is gonna run 8.5 meters. And then if you wanna get the exact answer, we could just plug it in, couldn't we?
Yeah, it's 8.7.
Yeah, so if you wanted the exact answer, you could have just taken your 2.5 meters right here and plugged it in right there for X. So if you do that, the exact answer would be 3.5 times 2.5.